Okay, good afternoon. So today we're looking at the fundamental counting principle, probability, exercise 1 on page 308. At this point you have discussed the why you would use the fundamental counting principle, and the reason for that is that it's easier to do the calculation, or it's an easier way to count the number of outcomes there are. Okay, it's a shortcut method or shortcut approach to getting the number of outcomes there are, okay, or even working out the probability for events to happen. Okay, so there's the rule 1. If one operation can be done in ways and the second operation can be done in ways, then the total possible outcomes of different ways in which both operations can be done is m times n. Okay, so that is rule 1. So I'm going to look at the examples and then the exercises that follows. Okay, so with these videos I'm going to do the examples and the exercises. So what I would suggest you do is you first do the example, okay, and then you watch the video to see where you went wrong or if you got it right, and so on. Always try and do the example or the sum first before you watch the video, otherwise it's going to become futile. Okay, so this is example 1, and this is on page 307. Okay, so in example 1, we are told a meal can be made up as follows: choice 1 and choice 2. Choice 1 is meat, fish, or chicken. So how many outcomes are there? There's basically 3. Choice 2 is mashed chips, baked potato, rice, or vegetables. So it's one of those 5 items. Okay, so if it's one of those 5, so how many options do I have here? 5. Okay, so it's either mash or chips or baked potato or rice or vegetables. Okay, so that would simply be 3 times 5, which is 15. So there's 15 ways of making up a different possible combination meals from this given information. Let's look at example 2, and example 2 is on the same page. Example 2, we told that the gift pack can be made up as follows. You have choice 1, 2, 3, there's 4 choices in total. Okay, so for choice 1, you can choose 1 CD out of 4 possible CDs, so it's 4 options there. Then 1 packet of chips out of 5 different packets, so it's 5. Okay, choice 3, choose 1 chocolate of 12 different types of chocolates, and 1 type of fruit out of 3 possible types of fruit. Okay, so that is simply straightforward. I'll just get my calculator. It's going to be 4 times 5 times 12 times 3. Okay, that gives us 720 different gift packs can be made up, or 720 ways. Okay, there's now example 3 on page 308. A gift pack can be made up as follows. Okay, we just did that one, sorry. Example 3, consider the word Parktown. Okay, you are required to form different 8-letter words, so we make 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 bits. Each bit would represent a letter there, or places, which is 8 placings here. Then we are told that they form different 8-letter word arrangements using the letters from the word Parktown. An example of the word arrangement would be, and they rearranged a possibility there. This arrangement of letters need not make any sense. Okay, how many possible word arrangements can be made if the letters may be repeated? So if the letters may be repeated, in the first case, the letters may be repeated, then I have 8 options here. So if I used P, I can use P again, and I can use P again. So in other words, there's 8. 8 would be an option for each bit all the time, if the letters may be repeated. So it's 8 to the exponent 8. Okay? If I look at B, B says the letters may not be repeated. 1, 2, 3, 4, 5, 6, 7, 8. The letters may not be repeated. Then how many options do I have here? I have 8. And then if I use P, then I can't use P again, which is then going to give me 7 options. Then 6 options, then 5 options, then 4, then 3, then 2 times 1. Then this could have been written as, so you could say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is simply going to give us 40320. Okay, 8 to the exponent 8 could be 1, 6, 777 Okay, now there's another way of writing this. Okay, if the numbers, and we have exposed you to these number patterns before, if it goes 8, 7, 6, 5, 4, 3, 2, 1, this simply can be written as 8 factorial. Okay, if it's 5, 4, 3, 2, 1, it's going to be 5 factorial. If it's 3, 2, 1, it's 3 factorial. If it's 6, 5, 4, 3, 2, 1, and it's being multiplied, of course, okay, it's going to be written as 6 factorial. That calculation is much easier. You just say 8 shift factorial. It's going to be 40320. Okay. Okay, if I had made any mistakes in these videos, please contact me on that number. Otherwise, these videos are free. Okay. I'm sure there's ways and means of doing these calculations easier, but okay. This just comes to mind as I'm doing these calculations. Okay, question 4. I want to know how many different ways are there of predicting the results of 5 rugby matches, where each match can end in either win, loss, or draw. So it's 5. So it's 1, 2, 3, 4, 5. So how many options do I have for the first one? I have 3. Either win, lose, or draw. Win, lose, or draw. Win, lose, or draw. So it's simply going to be 3 to the exponent 5. And 3 to the exponent 5, of course. 3 to the exponent 5. So it'll give you 243 ways. Okay, 243 ways. Okay, now we're looking at exercise 1 on page 320. At this point, you should have attempted all these sums and then just checking or marking from the video now to check where you went wrong and so on. Okay, a party pack is made of 3 items. Okay, by selecting one item from each of the following choices. So they have 3 choices, so it's 3 bids. Okay, choice 1 is Smarties, Astros, Jelly Tots, wine gum, so it's 4. 1, 2, 3, 4, yeah. Choice 2 is Coke, Fanta, Sprite, ginger beer, cream soda, so it's 5. And choice 3 is a donut, Chelsea bun, or a cheese roll, so it's 1 of 3. Okay, so it's going to be 60. It's 4 times 5 times 3, 60. So there's 60 combinations in which you can make up this party pack. Okay. For number 2, we have said consider the word Florida. Okay. You are required to form different 7-letter words. So it's 1, 2, 3, 4, 5, 6, 7. 7. Okay, so different 7-letter words. Arrangement using the letters from the word Florida. How many possible word arrangements can be made where letters may be repeated? So how many options do I have? If it may be repeated, so it's 7 times 7 times 7. 1, 2, 3, 4, 5, 6, 7. I have 7 options throughout as the letters may be repeated. So it's 7 to the exponent 7, which is a fairly large number. Let's look at B. B says the letters may not be repeated. So it's 1, 2, 3, 4, 5, 6, 7. 7 may not be repeated, and I use the F once. So I got 7 options there, and I use the R, then I have 6 options. If I had used the F and R, then I have 5 options left, then 4, then 3, 2, 1. As I explained to you earlier on, there's an easier way of writing this. It's going to be simply 7 factorial. So both calculations can be made. So 7 factorial is going to be 5040, and 7 to the 7 gives us 823543. So there's so many ways of doing it under those given conditions. Okay.